Okay, good afternoon, everyone. Today we have Quang Tran. He's going to present about non-destructive testing in concrete. His research focuses in the non-destructive testing of concrete using advanced sensing, signal processing, computer vision, and machine learning. He also works on the assessment of properties of concrete in the fresh state and contraction joints using advanced ultrasonic sensors. And he also was awarded in 2015 the HCI James Instrumented Award for non-destructive testing in concrete. Please welcome Juan.
Thank you. Thanks for introducing me. I'm so glad to be here today again. See everyone, this is friends. So before I start, I want to ask you very quick questions. Raise your hand if you heard or concerned about saw cutting. Wow, it's like it's new, popular. So today I want to share a topic research about that, how I determine the saw cut timing using two advanced techniques, including the ultrasonic and computer vision, to determine the saw cut timing, which is, I think, is very important and interesting to know. So before I go more detail, I want to thank you, the school, for giving me the funding to do this research, and grad students supporting me in this project too. And a good news I have is provisional patent has been applied for the research presenting here from our school, of course. So saw cut is very common in the concrete pavement. So, but let's see. It's to reduce the random cracking. But if we cut it, if you can see, if we cut it too late, then we have the problem is transfer cracking, random transfer cracking everywhere. But if we do it too early, then we will have a raveling along the joint. You see it here. So timing is extremely important in this case. But what we can do is just let these two guys, saw operators, decide when we have to do the saw cut. So a very challenging and very common question of engineering is, what is the time for saw cut? We can't be so independent on the saw operator. Sometimes it's right, sometimes it's wrong. So in my research, I want to create a device or use the technique to determine the saw cut timings scientifically and independently. So to do that, to answer the questions, I need to understand the history and the development of the raveling created by the saw cutting. So here's the damage block. The vertical axis is the damage index, times in the horizontal. And then we had three phases of the concrete during the early age and hydration. So if we do the cut extremely early, we will see a little bit of raveling and spalling. It's because that the concrete is still more plastic without sufficient mechanical strength to hold the aggregate. But as the hydration proceed, the concrete will have more strength. The concrete microstructures will be solidified and increase sufficient strength. That's why at that time we will see that more raveling until the concrete has a sufficient strength, stabilize the aggregate inside the paste. After the point, the raveling will decrease. And the raveling will remain low in the hardening. But if we cut it too late, as like I say, we will have a random shrinkage cracking everywhere. So the window here is defined a good time to do the saw cut. And my research is I want to find the earliest time to make the saw cut, then the latest time. Because if we make the earliest time of the saw cut, we still have chance to correct it, then the latest time. So there's my research conducted since 1985 to recent is 2015 to determine the saw cut timing using different techniques. But all of them have two main limitations, which is the access. And they must have the companion specimen next to the concrete pavement to test. And another research tried to evaluate and quantify the raveling damage using a JEIR, which is joint raveling index, from 0 to 3. They just use the coin here, put the coin next to the joint, and then try to quantify it by visual inspection. The limitation, as you can see, this method is just the relative quantifications. So my research objective is I know the limitation of the excess, and I know the limitation of relative quantifications. So I have two techniques. I use the ultrasound, the non-contact ultrasound, so I will eliminate the limitation of the excess. So it will find the final setting times of the concrete. The other technique, I use computer vision to precise quantification of the raveling damage. The objective is to determine, like I say, to determine the earliest time of the saw cutting using the final setting times from the ultrasonic technique to minimize the risk of raveling. So to do so, of course, I have to correlate this technique and the other technique. More detail I will show you later. Bear with me. So the test design I do is I create 6 mixed concrete. I just change the fly ash and water to have the varies the setting time and strength. So the first technique I want to introduce to you is the ultrasonic. So what do you see from these pictures? Look like a big mistake, right? Someone doesn't know when the concrete set, but it still roll on it. So it's very important for me to know when the concrete set. So that's why we use the ultrasonic and utilize the wave called the leaky Rayleigh wave. So how it works? Let me show you. This is the model. We choose layer. The bottom layer is concrete, and the top layer is the air. And if we imagine this one is the sound, the ultrasound that we send from the transducer. So let's see what we have here. So we see the sound go into the concrete, and we see some sound is along the surface, some ultrasound, and we see some ultrasound leak to the air. So this is the portion I want to care about. So I want to capture that wave I use the transducers, sending the wave, and the wave leaks to the air, and I will capture by 4 sensors. So here's the typical signal I have. So the big wave here is the direct wave from the transducer that I don't care about that one. The one I want to care is this small section here, which is the leaky wave signal from the surface of the concrete. So if I stack all the signal together, then I will see that, okay, firstly, when the concrete not yet set, doesn't have enough strength to hold the shear from the wave, then we don't see any signal. But after that, when the concrete set, it develops a sufficient shear strength, then the wave going to appear. and leaks to the air. That's why we capture it. So you see over time, the signal will be clearer and clearer. I calculated wave energies over time. Then you see here at the beginning, there's no wave energy. But then when the wave appear, the energies move up radically. So at this moment, I define at the final setting times of the concrete. So here's the result that I found from the 6 mixtures. They have different times, they have different standard deviation, but they also have very low coefficient of variance. It's showing the precision of the technique. So the second technique I want to apply is to evaluate the raveling damage of the concrete precisely. So what I do? So this is the slab cement I make, the concrete block with the size of 500 and 450 millimeter. I will make the saw cut subsequently, and at 50 millimeter away, every, I like say 30 or 1 hour interval. So firstly, I make an image. After I cut the sample, I will make the image of all of them. And I will build reconstruct the point cloud and build a mesh. So based on the mesh of each cut segment, I'm going to analyze the mesh to see that what area going to including to show the damage. So as you can see the schematic here. So what I see is I make a histogram of the z-axis, which is this direction across the mesh, and y-axis is the axis like perpendicular to the surface. So what I see is, you see it, whatever below this surface. Oh no. Firstly, the z-axis will tell you where's the saw cut, where the groove, the 2 sides of the saw cut, which is I don't care, because it's not the damage, right? It's not the spalling damage. It's just the saw. So I need to eliminate this area first by using the z-axis histogram. So these 2 peaks will tell me where it's the groove is, the 2 sides. And this histogram will tell me where is the damage will be, right? Because the surface here will tell you, okay, so most of the flat surface will be the peak. So that's the first technique I use to detect the damage below the surface. So some damage will be above the flat surface. So I use the different techniques. It's called surface normal. So whatever you see the surface here is flat. So it means that the surface normal should be perpendicular to the surface, right? And if the damage, which is the surface normal, is going to be different than 90 degrees. So that's the 2 techniques I use to define where is the damage is. So based on that one, I will measure the damage of each cut that I make in the whole block of concrete. Like I say, like every 30 of an hour's interval. So what I see here, you see, firstly, we'll have small raveling, but then it will increase, decrease, and decrease, right? Based on this observation, I will plot is the time variance damage index. So I found the surface area of the damaged element, and I try to normalize by the length of the saw cut and the maximum size of the aggregate to have the damage index. And I plot some over times. Here on the left side is the damage index of 3 Portland cement concrete, and the other side is the 3 tonnages concrete mixers with the fly ash and different water cement ratio. So I will correlate what I found in the computer vision quantified damage with the setting time found by the ultrasonic. Then here's I found the times that we had the peak damage, which is this peak. The time that we had the highest raveling damage. And I correlate with different times of like 10%, 5%, or 3%. 5% means that the time that the concrete have 5% of the damage, raveling damage index actually. So based on this, I really don't know when gonna have what do I have to do if I decide setting time to have a 10% of the damage, or have 5% of damage, or 3% of the damage. So I'm thinking that okay, we need to find some damage which is like acceptable by all the engineering, or at least by the saw operators, experienced guy. So that make me to go one step further. Go to the site, different site, 10 different site, 10 different location, 10 different saw cut, up to I think a 2 or 3 project in Champaign and Urbana. I quantify them using this computer vision technique. And what I found is they varies, of course, but they vary from 2 to 6%. With the mean is 3% and the standard deviation of 1.2%. So let's say that if I take 3% as the acceptable damage index, then what should I do next? So let me show you once again the flow chart that I'm trying to do in this project. So I will find the damage index history over time in the lab. I go to the field and try to find the acceptable damage index. And I establish the saw cut timing between the saw cut, the time of saw cut and the acceptable damage index. I correlate with the setting time using ultrasound and establish the relationship between the saw cut and final setting times. So of course we have this in the plot already. So what we have to do, what we found is very important. It means that so we can make the saw cut later 30% later than the final setting time plus 40 minutes. That's what defines the earliest times that we can make the saw cut based on the ultrasonic indications. So any questions here so far? And I'll go fast. Yes?
The setting time that you determine from the ultrasonic methods, are they correlated to other set time measurements?
Yes, so what I did before is I did ultrasonic and pin penetration test according to the SDM. Then I correlate them. It's matched, I think, very high like coefficients relation.
One other question about the material presented so far. The saw that was used in the laboratory specimen, the rectangular piece you cut, was it comparable to like commercial saw, joint cutting saws that are used on pavement, such as what?
Yeah, I don't use exactly the one they use, but I use the same technique to use, which is the dry saw. Sure. Yeah, so of course I cannot afford like the big saw like they have.
I'm just saying there was a major improvement in saw cutting technology some years ago.
Yes.
Like the soft cut saws and that, and I didn't know if what you used in the lab was similar, like blade RPM and things of that nature.
Very similar, very similar. Any other questions? So I would jump to the conclusion of this. What I found is I make a lab and institute measurement method to predict the initial time of the dry saw cut. You can see the dry saw cut, not the wet one, to minimize the joint raveling. And the ultrasonic here, I found to estimate the final setting times. The results look like it follow expected trend, for higher setting time for the higher water span ratio, and with additional fly ash, of course. And the techniques have the maximum standard deviation and the coefficient of variation with 21 minutes and 8%, showing the accuracy of the technique too. So the computer vision, it can detect the raveling damage and it's quantified. So imagine that all the engineers, like contractor and man contractors, come to the site and then say, this is a good saw cut. But this is too relative. How good it is, we don't know. So this technique will help them to quantify it. At least, like I say, so in the contract, so cut it. So as long as I have like 3% of the damage index, it's acceptable. And then the operator, the saw operator says, okay, I cut it, I check it, it's 3%, so I commence on the cut for the long concrete pavement, right? So it's going to save a lot of cost at the beginning for both of them. So, and this technique is very useful too for the QA, QC and less experienced personnel to use. So he just needs to present it aside and then predict the setting times and tell the saw operator to commence on the cut. Other than like they just wait a couple hours there, paying $100 per hour, and then do nothing. So imagine one project can save a couple $100, but we have a lot of concrete pavement, and then it saves a lot of money, really. And it's like I say, it provides an agreement between the engineer, contractor, and saw operator on the acceptable criteria. Yes.
For implementation, and maybe you're going to get to this, in the field, would they use similar ultrasonic equipment for determining the setting time?
They never use, but I use.
But I'm saying, so this 1.3 of time of final set plus 39 minutes, to pinpoint that time, they have to know the time of final set.
Yes.
Are you proposing that they use an ultrasonic method, or like the previously determined set time for that mix? Because that could vary due to environmental conditions, so humidity and temperature, say.
Exactly. So on the field, what they used to do to know the setting time, like I say, is maybe they use some knife or some crash, they crash on the surface. If it's good enough, then they say, okay, the concrete set, I'm good to go for pouring the curing compound or do the saw cut, right? But it can vary here and there. So because like you say, the temperatures, the wind, the environment factors, whatever you call it, but it using mine, so it tell you, it gives you indications that the concrete, at the surface, it have enough the shear strength to carry the wave. It's been strong enough, right? So I would say this is the indication, but the good point of this one is it gives you the earliest time. So like if you make a wrong mistake at that time, you just have to wait another 10 minutes. Other than just based on them and then just crash and then make like 100 cuts and then figure out, oh my God, this is totally wrong. I cannot recover on the cut, you know. And all the cut can make like extremely harmful to the concrete because the increase of the solve or loading.
What I was getting at specifically is to implement this in field applications, are you promoting the use of that same ultrasonic type measurement to determine that T-SDF?
Yeah.
Okay.
So that said, this is my presentation. And then I'm welcome to any question from audience.
So next presentation.
Thanks.
So you concluded a linear relationship between the setting time
and the earliest cutting time, right?
Yeah.
A linear relationship.
Yeah.
So I was wondering, how do you know it's actually a linear? So between like those points, it's kind of linear. What
Yeah.
about below the, like on the two other sides? So do you have support for this linear relationship, or you just assume it's linear?
I don't assume it's linear. I plot, and I see that if you can see it here, linear have pretty high coefficient of determination. Here is low, right? But it increased.
Points like below the.
Lowest number and the points above
You mean
the
in
highest.
here, in
Yeah,
this
yeah,
area? So usually final setting time is not going to be low here.
Oh.
It will be somewhere above 200, unless you use like very quick accelerator. But I don't think it could be.
And one more question. So how did you reconstruct the point clouds based on the image? So what? How do you like obtain the distance information?
So you take the phone, and then take the image, the series of image. I use it in each cut. I use 100 image. So and then 2 consecutive of image. It must have at least 50% of the overlap. So 2 images, they will find the same features, right? And then you have 100 image. So those features will build the cloud, the point, the common point, and start to build the 3D point cloud along a cut.
Yeah, I just don't understand how, like, do you know the
Distance
distance?
information, because from image you only know like the pixel number, like
Yeah.
the color of it. How do you know like how far it is?
You know,
from the-
based on your phone have the focal point. It will give you the information about that one. And they use the triangular technique to identify, because you have the phone here, you have the phone here, it triangulate in the same point, it should find the distance and where it is from the inner space. Yeah.
So the various mixes that you utilized in the study, like the C39, is that, what was the range of compressive strengths?
I didn't test that.
You did not test that?
Yeah.
All right. Because I was just,
But we know that the lower water cement ratio is going to have higher strain, right?
Sure.
Yeah. I'm just based on that knowledge to say that it's varying the compressive strain.
The relationship is fairly consistent across the range of mixes.
I think so. Yeah.
We find out the time that the people are so cutting the 6 places you visited in Urbana-Champaign.
No, I didn't. I'm just characterize quantify the raveling damage. I don't really know when they cut.
Usually they don't wait all the 4 hours, because now you're over 200 and something.
Which one is 4 hours?
Your minutes of setting that you're proposing. 240.
76?
Yes.
It's just a set time.
From when they place the concrete, right?
Yeah, after they place the concrete.
Yeah, that's what I'm saying. They usually don't wait that long, and they still got good.
Maybe they use the accelerator. That's the only case they don't. This is I don't use like a lot of accelerator. I use just little. But if I use the accelerator, I will be more careful when I do the first cut. I will do it earlier than longer. So.
Any more questions? So let's take one.
Thanks.